So the basic 7 you are used to using. But it's the ones out here, the mega, the giga, the tera, that you might not be as familiar with. The ones down here, micro, nano, and pico. This is one way that at least hopefully you'll be reintroduced to them and know how to use them in conversions. Now, if you haven't learned it this way already, I'll tell you my handy dandy method for remembering the 7 orders. The King Henry method, did you learn that method? Maybe in grade school. King Henry drinks up delicious chocolate milk. And that's the way that I remember the 7. Of course, you can just have used them for so much that you know them already also. Now, my sons, when they came home from elementary school, said that kids have dropped, they use O, open, over, dead, converting metrics. I don't particularly care for that method of memorizing it, but whatever it takes for you. Hopefully you have at least these 7 and now the extra ones. Now, when you are converting, you use a process that we call dimensional analysis. Again, I cannot stress enough to show all your units, show your work. Even in these conversions, you have to communicate how you get your answer. So if you want to be moving decimal places left or right, as long as you've shown me the basic setup, you'll be good to go with that. We want to convert 0.0537 centimeters to meters. So I start with 0.0537 centimeters. Write down what you know you have, and then use the next step to do the conversion. Can we go directly from centimeters to meters? Yeah. All right. So we want to change to meters, and we want to get rid of centimeters. This is the dimensional analysis part. So I always ask myself, and again, whatever method works for your brain is fine. Which one's bigger, a meter or a centimeter? A meter's bigger. I put a 1 there. A centimeter, there's 100 centimeters in a meter. And that's the method that I will use. Now I just go move my decimal place because I'm dividing by 100, 2 places to the left, 0.000537 meters. There goes my units. There I have my setup. There I have my answer. And I'm going to put a box around it. All right. If you want to use 0.01 meters here and 1 centimeter there, it's perfectly okay. Just please show your work. Now we want to go to nanometers, and this is where I think it gets a little bit sticky. 0.0537. We're starting with centimeters. They want me to go to nanometers, way down here. Now if I have this little chart drawn, 1, 2, 3, 4, 5, 6, I can count, 1, 2, 3, 4, 5, 6, 7, 8, 9. I can count all the way to nanos and do it from centimeters. Here we go, 1, 2, 3, 4, 5, 6, 7, immediately. If I don't have this chart ahead of me, I would like to take it to something that I know. Rather than going just directly from centimeters to nanometers, I know how to go from centimeters to meters. That's something that I'm familiar with. So I would probably do an interim step here and go to centimeters first. 1 meter is 100 centimeters. And that gets me out of meters, or excuse me, out of centimeters and into meters. Now, I do know the conversion from meters to nanometers. I have memorized nano, -9. So I can get rid of meters and I can go to nanometers very easily. Which one's bigger? A meter is bigger, it gets a 1. And a nanometer, there's 10 to the 9th nanometers in a meter. Now again, this is 10 to the -9th, but that's how many meters there would be in a nanometer. So I cross these out, and when I do the multiplication, I get I'm going to change it to scientific notation here too. 5.37 times 10 to the fifth. 5.37 times 10 to the fifth. This would be in nanometers, and I'm going to box in my answer there. All right. Oops, sorry, running off the page here for you. There we go. All right, again, whatever method you choose for making these conversions, you're going to be good to go as long as you show your setup. Now, I'm not going to deal with the kilometers here. You can do that for extra practice if you'd like. Just FYI, the answer is 5.37 times 10 to the negative 7th kilometers. So give that a try. See what you can come up with there. All right. Okay, let me go on to converting a density. We've got 4.85 grams per cubic centimeter. We want to go to kilograms per liter. What are you starting with? Right, 4.85. We have grams per cubic centimeter. Now we want to go to kilograms per liter. And the reason I'm showing you this one is that we have 2 units that you have to convert. So we're going to change, I don't know, which one do you think you want to do first? You want to do grams or you want to do cubic centimeters? Okay, all right, well, we'll do grams then. All right, we want to get rid of grams and we want to change it to kilograms. Can we do that in one step? Yeah. All right, there's the kilograms. Which one's larger, a kilogram or a gram? Kilogram, right. So this gets a 1. The gram, how many grams are in a kilogram? That would be 1,000. So this is just the method that I'm choosing to do this. The grams are gone and we'll be left with kilograms. All right. Now we want to go from cubic centimeters and we want to change it to liters. The cubic centimeters is in the denominator. To get rid of it or to change it, I would have to put it in the numerator. Is there a relationship that you know of that goes from cubic centimeters to some sort of volume measurement? Yeah, remember in the first part of the lesson, we changed from cubic centimeters to milliliters. Oh, actually, yeah, it was right back up here. We went from cubic centimeters, or from milliliters to cubic centimeters. What's the number to change them? 1. Yep. And we're out of cubic centimeters and we're into milliliters. The only problem is they don't want me to stop at milliliters. They want me to go to liters. So we do have another step here. We want to get rid of milliliters. I'll put it in the numerator. And we want to change. Can we go from milliliters to liters? Yeah. All right. It's part of our chart up here. Which one's bigger, a liter or a milliliter? A liter is bigger. It gets a 1. And there's 1,000 milliliters in a liter. Milliliters will cancel. And we're left, dun, 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 in kilograms per liter. All right, now grab, nope, do not grab a calculator. First of all, you're only multiplying or dividing by factors of 10. Second of all, you see 1,000 in the denominator, 1,000 in the numerator. They're going to cancel out anyhow. So guess what? After all that work, the decimal part doesn't even change. It's 4.85. It just happens to be kilograms per liter. And like a good chemistry student, I box in my answer so my teacher can find it easily. There we are converting with 2 different factors. There are 2 different units.